Thanks, Simon. Now, at times, making games can be hard, expensive, and slow, where the gap between what you can imagine and what you can make is held back by technical overhead. I don't know about you, but spending hours in a node graph trying to untangle and understand what's going on just to change one thing is not my idea of creativity. There has to be a better way to do this. So that's what we've been working on, tools that enable you to build faster and iterate more. Now, Unreal has been built on a simple idea: your source, your pipeline, your workflow. Give developers complete control over the tools and get out of the way. That philosophy hasn't changed. We're just applying it to large language models. Now, in 5.8, we've implemented an MCP server that acts as a bridge between Unreal and any model that you want. For this presentation, we're going to be using Claude Code, but you can use Gemini, your own custom model, whatever you want. Enabling the Unreal MCP is as simple as turning on the plugin, doing a bit of config, and connecting to the model of your choice. And everything you're about to see today runs on that setup. Now, these are still early days, and models will still do some really unpredictable things. However, with this approach, we maintain the ability to go in and edit as you would any Unreal scene. OK, let's see this in action. On the left, we have Unreal Engine. On the right is a terminal running Claude Code. You can see every message going back and forth. Claude Code is talking to Unreal through the MCP server, reading the scene, and taking actions directly inside the engine. So let's start with something small, a modern living room. We start by giving the model some context, what we want to build, and whereabouts in the level. And to make sure everyone can follow along, we're showing a summarized version of each prompt as we go. But if you want the full details, you can still see that in the terminal window. We're going to speed things up from here for presentation purposes, but everything you're seeing is real work happening inside the engine. So we can ask for the basics: a sofa, a rug, and a coffee table. Then fill it in with chairs, a lamp, and a side table. Semantic search, which is part of the 5.8 release, pulls assets from your library that fit that description. And because this is Unreal, we can also manually add a chair, describe it as a reading nook, and the model will furnish the room accordingly. Every step here is a creative decision that you're making. Models are good at broad iterations. You're good at knowing exactly what you want. Those same principles work whether you're furnishing a room or whether you want to scale up and build an entire city. So let's take that same approach and build a city. You start by drawing the boundary. From there, you can decide where the districts go and what characteristics each one has. Highways cut through on your direction, and from those, the road network starts to fill in. Buildings come up. The model here is using semantic search to find the right assets from your library and place them in the level. Ask for a forest around the edge, and it can fill that in. At every step, you're making the calls. What do you end up with? It's not a rendered image. It's real geometry, real procedural content generation graphs that you can open, edit, and modify. And this works for a whole team, too. Other developers can work on their own sessions, building assets and dropping them straight into the city. The road network adjusts, the blocks update, and the city absorbs it. Different people, different sessions, and it all works together. So how does all of this actually work? With the MCP server as the bridge between Unreal and your model, it gives your model the ability to read your scene, understand your assets, and make changes directly in the engine. And because it's open, you're not locked into any particular model or workflow. Now, while large language models are great at language and reasoning, they don't naturally think spatially. Unreal does. To help connect the two, we're giving you over 80 foundational procedural content generation building blocks, a library of examples, and skills that encode specific Unreal workflows. Now, this is experimental, and it's going to keep getting better. This is where you come in. Tell us what's working. Tell us what's not. That's how we're going to make this better. Now that the city is built, we want to light it. Getting lighting right on Unreal is a skill that means touching dozens of parameters that all need to work together. Light balance, cloud materials, sky atmosphere, post-process. That's a lot to know. But by creating a dedicated lighting skill, you just describe what you want, and the model orchestrates that all for you. Ask for a purple dusk. And there it is. Under the hood, it's adjusting all those settings in concert. Then we can ask for overcast skies. And this is a good example of where the model gets things wrong. It misread the sky and tweaked the cloud material the wrong way. But you can see exactly what happened, correct it in the next prompt, and you're right back to where you want to be. Because models also have real-world knowledge, you can just say, Bogota at 9:30 in the morning. And it will go and figure out the sun position, direction, temperature, and atmosphere that actually matches that. And if you want to match something specific, you can take an image. So here we used one of Vancouver, and ask it to replicate that look. It uses screenshots to assess and iterate until it gets there. And everything is still editable. Grab a road and move it, the city adjusts around it. Ask it to make a building taller or more prominent in the scene, and it does that. But then you can go in and modify any individual asset, making it exactly the way that you want it. This isn't a generated image that you're stuck with. It's a real scene in Unreal, and you control every part of it. Now, let's look at one intersection. We wanted to add a hazard zone, flashing lamps, steam, and a sense of danger as the player gets close. That normally means days of back and forth across multiple disciplines. So here's what we did instead. The warning lamp already has a material. But let's say you want to add something to it. You ask the model to read the existing graph, build the new logic, and insert it right where it needs to go. You can then jump into the material instance editor and tweak the final values by hand. Then you take a Niagara template and extend it, adding a single parameter that drives multiple emitters at once, giving you control over the whole effect in one place. You build out the HUD through prompting and UMG, status display, danger meter, warning states. Then blueprint logic ties it all together. A proximity trigger connected to the material, the Niagara system, and the HUD. Walk in, and everything fires at once. All right, so let's run it. Lamps are off, it's quiet. She walks toward the site, the lamps come on, the steam starts rising. She steps inside, lamps are flashing, steam's pouring in, and the site is erupting. What we've shown here today would take months to build by hand. But with the MCP server and Unreal, our artists were able to make all of this in days. When you lower the technical friction, you can iterate more and make better games. That's what we've built. This is really just a starting point. Bring your own primitives, your own examples, your own skills built around your pipelines. The more your team puts in over time, the more useful it gets for everyone on the project. We're shipping the MCP server, the PCG primitive plugin, and the skills we've developed as part of 5.8 today. It's open, and it's yours to extend. Go download it, point your model at it, and see what you can do.